Let me turn this down because I think it's gonna put right there. Ho ho ho. Okay, that seems like it's working. Okay, we're gonna go with it for now. All right, welcome, gentlemen. I just sorry for the delay. You know, technology being technology. Like I was getting ready to start the Zoom, then the computer crashes. I'm like, ugh. So I had to like reboot everything, and then it's like I guess with updates, things are not behaving like they usually do. So I had to let some stuff go and just go with it. I've just taken attendance. I'm just trying to fill the dead air while I take attendance. I don't know. Everything seems like it's moving kind of slow today too. Let's go here. We're almost there. Okay. I think I got these two gentlemen. Okay. So yeah, this is it. You guys, let me get these two in. So you made it, right? This is the official last day of class, right? So we have finals next week. Let me get this student. Yeah, we have finals next week. So my thought process is I want to make okay. So all of our old assignments, that means old exams, old quizzes, and old homework, those are going to lock out this upcoming Monday at 9 a.m. Right? Yeah, this upcoming Monday at 9 a.m. At that same time, I want to go ahead and make my portion of the final available. Right? So there's the final is a little bit different. Because I'm going to give you a portion that's similar to what we've been doing, but then the school has like a common final exam, and that's not going to be available until like late Thursday. I'll be in communication via the announcements section with full details about the final because it's a common final. I think it's going to be on Blackboard, and more than likely it won't be available until like 6:30. So you want to be prepared, just be available remotely until like late Thursday for our final. You can anticipate the final being cumulative, so everything from the beginning to the end. That's pretty much all of chapter one. In chapter two, we did 2-1, 2-2, and 2-3. We also did 3-1 and 6-4. On Monday, we did the best we could to get through as many questions from chapter one as we could. So today, I want to take time to go through as many sections of chapter two, section 3.1 to 6.4 as best we can. And again, I'm just feeling the air with this. But if you want me to like go to specific questions, that works. To prepare for the final, I would study old exams. So just kind of keep practicing your old exams. That's going to be the most comprehensive thing. Um, yeah, and so if you have questions, just type it into the chat. I'm going to suppress my audio so I can focus. And let's hop over. Let's hop over to Pearson. Okay, and let me hide this. Okay. So this is starting with chapter two. So again, in chapter two, we did sections 2-1, 2-2, and 2-3. And I'm going to try to get through as many questions as I can as quickly as I can. So I might be moving a little quickly. So what this is, I'm basically retaking exam 3, I think it is. This is exam 3. Let me see. Yeah, it should be exam 3, but basically talking about chapter 2. It says choose the graph that represents the function, right? So this is a parabola. The highest exponent is a 2, and we can get the general sense of the shape by transformations, right? So we know it's a U-shaped graph, and when we do transformations, we work our way from the inside to the out, right? So this says to go right 9 and down 3. So if we have a U-shaped graph that went right 9 and down 3, those are the only transformations. So then that's going to be this guy here, right? We're just going to go with that. We won't be able to see if it's correct until a little bit later. I know we kind of got a late start. I'm trying to think if there's anything else. I do want to say that I'm proud of you guys. Like I know it is what it is. It's a challenge, right? It's a challenge. That's how life is. You make a plan and then you have to adjust in the flow, right? And so just I always just encourage people to just do their best. And then once you've done your best, it's okay. Like no matter like another thing is like no matter what happens, it's okay. Like as humans, I don't know why we'd be so afraid to make mistakes, but a lot of people are just afraid to be wrong, right? But you got to get past it. Like that's the only way is to get into the quote unquote right. You have to be wrong at some point, right? Nobody knows everything all the time. If we knew everything, we wouldn't be here. We would be in the cosmos, you know. But as a human, we're supposed to be wrong until you figure it out, until you learn the lesson. So I always encourage people to do your best. Do your best, forget the rest, don't stress, and be blessed. Um, there was something else I wanted to say. And know that, like, no matter what happens, there's always another way. You always have a choice, right? Don't ever feel like you don't have a choice. No matter what you're experiencing, you always have a choice. You know what I mean? And like that should give you some solace. Be like, okay, well, and if you ask me directly, this is all a game anyway. Like that's just how I feel. Like I don't, So I just say that to say, you don't have to take it so serious. Do your best, play the game, have fun. But then once you've done what you can do, just let it go. It's okay. And just, you know, you know, it's like that thing where do you see the glass half empty or half full? So like I consider myself paranoid. I don't know if you know what the term paranoid means, but you should know what paranoid means, right? Paranoid means, you know, you go around every corner looking for something bad to happen. Oh, what's bad about to happen, right? Well, paranoid is where you go around every corner looking for something good to happen. Oh, I wonder what's going to happen today. Who am I going to meet? Oh, what kind of unexpected money am I going to get today? Like, it's stuff like that. Like, but it's all a choice and it's all perspective. You can have two people experiencing the same thing, but if one person sees all the bad stuff and is pessimistic, and another sees all the possibilities and is optimistic, but they're both in the same room, then what's the difference? Like if they're experiencing the same thing, what's the difference between one person and the other? And I'll finish this little rant with this story. And the story of the two wolves. Ooh, what is that? The story of the two wolves, right? You have one wolf of like despair and hatred, and the other of like hope and light, right? And so these two wolves are battling and they're fighting and they're battling for eons. So which wolf wins? Whichever one you feed, right? So whichever one you feed, that's who comes out on top, right? Ultimately, you always have a choice. Don't ever feel like you don't have a choice. And if you're talking to anybody, any kind of official or anybody, and they're not saying what you want to hear, you're probably just talking to the wrong person. You just got to find somebody else to talk to that's going to say what you need to hear and what they need to say, right? So it doesn't matter like if it's a professor or whoever. If you're talking to somebody and they're not saying what you need to hear, you're probably just talking to the wrong person. You got to talk to somebody else and keep going until you get there. Okay. I just wanted to kind of share that since it's fresh on my mind, and I can, hopefully my recordings are working. I told you I was having so many technical difficulties today and it seemed like it's still kind of loud, but it's okay. We're going to have to go with it. Okay. So let's see what else we can find. And like, I'm really just trying to skim. I want to skim and like just touch on things. Find the quadratic function of this form that passes through these points, right? So it's something like this. They give us an x and they give us a y. So we plug in for x and we plug in for y. Also, if we're ever like taking an exam, or you can ask me questions. Like, I don't think anybody has asked me. Like, I may have had like one time a student asked me like content questions the whole semester, but like even during the exams, during the final, you can ask me questions about that stuff, but nobody ever does it. So I just like, I can't make you ask questions. So I just like, okay, I just sit here and I just be available. But you can ask questions, and a lot of times, I mean, I'll give you practically most of it just shy of the answer. I'm not going to just give you the answer, but I'll give you like a good amount of it. But I think the biggest challenge is getting students to like overcome their anxiety. Like I think the biggest challenge is just the analysis paralysis and so afraid that they're frozen. Right? It's like it's not. You just got to take a deep breath and try. You know what I mean? Find the quadratic function of this form to pass it to this point. So if we plug in for x and y, so if we plug in for x is 3, that's a 9. 36 divided by 9 is 4. So then that means that a should be 4. So then the function should be 4x squared. Right? Hopefully that makes sense. I'm going to go with this. So if we plug in 3 into this, 4 times 9 is 36. I'm going to go with that. Okay. For the following problem, find the quadratic function that has a given vertex and whose graph passes through the given point. Write the function in standard form. We have this vertex passing through this point. It says quadratic function, right? Let me think about it. Okay. So with the quadratic, there's a couple of places we could start. I was originally tempted to start with ax squared plus bx plus c. I mean, and I think it would work, but I think even more simple than that would be what? The standard form of a quadratic? Am I thinking about that right? Yeah, let's give this one a go. I'm watching the clock as best I can. I know we kind of got a little bit of a late start, but I want to try to honor the time as best I can. So what I'm going to do is take some notes. Let me get my paper ready. Hope everyone, other than, school being what it is, I hope everyone's been having like a good holiday and get to be around loved ones and, all this jazz. Paper. This one. Okay. All right. So this is question number 3. This is what I'm going to say exam 3. This is question 3. Comes we want a quadratic. So I'm going to say find a quadratic. And again, I'm just taking some notes. We'll hop over that momentarily. Let's see, it says the vertex. Let's see, did I get my notification? Come on. Sorry about this. Cool, okay. The vertex is 1, 2. And it passes through, it's passing through 2, 5. Okay, let's hop over to the tablet and take a look at this. Okay. We'll go like this. Cool. So we're asked to find a quadratic function with that vertex passing through this. Let me see, the standard form of a quadratic. Am I thinking about that right? Something of the form like, let's say y equals, there's going to be a times x minus h squared plus k. All right, does that look right? Let's go with this and see what happens. All right. Okay. So now they gave us the vertex. So if that's the vertex, that means this is our h and this is our k. And then if it's passing through this point, then this is going to be our x. This is going to be our y. Okay. So then let's plug in what they gave us and let's see what do we need to solve for. So y is 5, a, we don't know a, x is 2, h is 1, and our k is 2. Hang on. Yeah, we're good. Okay. So based on what they gave us, the only thing we don't know, so my Zoom still working? Okay. I don't know. Yeah, like these updates. Okay, let me try something. I think maybe I'm missing. Let's share. It should be this one and this one. No, not that one. This one. Share. And then if I hide, oops, not that one. Hide. Okay, that looks better. Okay. So again, the only thing we don't know is A. We plugged in, so they gave us the vertex. Let me see. They gave us the vertex. They said it was passing through this point. This is the standard form of the equation of a quadratic. And then we basically plugged in all the different components of what they gave us. The only thing we don't know is A, so let's solve for A. So then we'll get 5 equals A, 2 minus 1 is 1, squared is 1, plus 2. So then A equals 3. All right, I did it a little fast, but I think you can handle it. So then the quadratic that we get is y equals 3x minus 1 squared plus 2. So in this form, we're saying that it should be a parabola that's been shifted to the right by 1 stretched vertically by a factor of 3 and moved up by 2. All right, but let's hop back to Pearson and answer the question that was being asked. Okay, type your answer in standard form, f of x, okay, 3 parentheses x minus 1 squared plus k. No, sorry, plus 2. Okay, we're just going to go with that. Determine the quadratic function of this form whose graph is given. They give us basically the same thing. They give us a vertex and a point. We should solve for a. I'm just going to do it very quickly. It's basically a repeat of the last one. It's just presented a little bit differently, but it's the exact same question with different numbers, all right? So the vertex they give us, I'm just going to do this real quick. I'm not going to show the notes. Is negative 2 comma 0. A point on the parabola is negative 1 comma 1. We're working with f of x. F of x equals a times x minus h squared plus k. Okay. Let's see. Our y is 1. A we don't know. X is negative 1. H is negative 2. And k is 0. Oh, the lights. These lights are a trip. I'm over that light. 2 minus 1 is 1, so it looks like a is 1, right? So then if a is 1, we're going to have f of x equals x plus 2 squared on the k, and that's it, all right? X plus 2 squared. Again, this is just a repeat of what we just did, just with different numbers. X plus 2 squared. That's not squared. So let's see, when x is negative 2, y is 0. When x is negative 1, y is 1. Okay. Next. Let's see, it says graph the given function by writing it in standard form. Let me work this one. Because this one we need to do completing the square, and completing the square can be a little bit of a challenge if you're not comfortable with it. Even if you are comfortable with it, it can be a little bit of a challenge. But let me see, this is question 5. We have y equals 2x squared minus 20x plus 51, and we want to write it in standard form. Okay. So if we're going to write this in standard form, the first thing is that the leading coefficient needs to be a 1, and right now the leading coefficient is a 2, so that's going to kind of create some fractions for us. So, but we need to factor out a 2 from every term. So then we can do the following. If we factor out 2, we're going to be left with x squared minus what, 10x? If that's 51, I'm gonna leave some space. I'm gonna say plus 51 over 2. Okay. So next, to completing the square step, we have to say, the way I'm going to do it right now, I'm going to say plus or minus b over 2 squared. B over 2 squared. Okay. So the b in this case is 10. So it's like I'm really just adding 0 in that form, right? I do need a little bit more space. So I'm going to move over here. Y equals. So this 2 is going to stay. X squared just comes down. The minus 10x comes down. Now we say negative 10 divided by 2 is negative 5 squared. So what we're doing, we're saying plus 25, and I'm also doing minus 25. Because again, adding 0 doesn't change our answer. We're just changing the form into something that we can use, right? So now what I'm going to do, I want to distribute this 2 into the first part and the second part. I want to make sure that the two different parts are being multiplied by 2, right? So then we'll get I'm going to leave the 2 in front of this. Also, these first 3 terms factor. So they can factor into, I think it's x minus 5 squared. Okay. What is that? Is that 25.5? So that's a half. So then it looks like what we're doing is 2 times this negative 25 plus 51 over 2, right? Half of 50 is 25, so half of 51 is 25.5. 25.5 minus 25 is 0.5. So then 0.5 times 2 is 1, right? So then ultimately we get this plus 1, okay? Let me see. Did I do that properly? Okay, so if we wanted to check this, I think this is fine. Yeah, I think this is okay. Because like if we expand it out, we should get back to the original. So let's hop back over to Pearson. I'm going to go with it. Let me think about it real quick. That's going to be plus 25 minus 10x, 50. It becomes 51. Yeah, I'm going to go with this. Okay, let's hop over to Pearson. So write the given function in standard form, right? Type in equation. It says y equals, so we're going to say y equals. Now we got 2 times, oops. We got 2 times x minus 5 quantity squared plus 1. Now I know like just completing the square can be a little bit of a challenge. I would suggest doing some research on it, like look at some YouTube videos on it, other than the way I'm doing it, and just see what different people, are saying, like the techniques that they use for completing the square. An equation, use a graphing tool, the vertex. So the vertex is what, 5, 1? 5, 1. And the axis of symmetry is x equals 5. Let me check the chat really quickly. Okay. And then I think we need to graph it. It says that my connection is poor. So we're working with a parabola. I'm just going to click on the origin for right now. Okay. We said we went to the right by 5. And then we went up by 1. And then we did a vertical stretch by a factor of 2. Uh-oh. Because we multiplied the outside by 2. I think those are the transformations. Let's try that again. Let's clear it out. I don't know. Let's clear it out. Why does it look like this? Let's try this one more time. We're here. We click. Okay. So we said we went to the right by 5. We did a vertical stretch by a factor of 2. And then we went up by 1. Okay, that looks better. Now, see, what you could also do is like put this original equation in like your graphing calculator. Something feels off, but we're gonna go with it. Let's just go with it. Oh, wire intercept. Okay. Yeah, I was kind of confusing myself because I was confusing the y-intercept with the vertex, right? The y-coordinate of the vertex. I was like, why am I getting plus 1, but the y-intercept is 51? So yeah, it crosses the y-axis at 51, but the vertex is just up by 1. Okay. Identify the x-intercepts. I don't think we have any, right? There are no x-intercepts. Then the y-intercept, if you set x is 0, the y-intercept is 51. 51. What's the time? Okay. I think that's everything. For this equation, determine whether the graph is the quadratic function opens up or down. Find the vertex. Okay. So let's start here. Does this parabola open up or down, right? So the orientation of the parabola is, it comes from the leading coefficient. The leading coefficient in this case is positive, so that means that parabola opens upward. Okay. The vertex of the parabola, so there's a vertex formula. I think it's negative b over 2a. That's going to be the x-coordinate. So the x-coordinate of the vertex is going to be negative b over 2a. So 10 divided by 2. So the x-coordinate of the vertex is 5. Okay. And then if we plug 5 in, that'll give us the y-coordinate. 5 squared is 25, minus 50 is negative 25, 16, negative 16. We got negative 16. Axis of symmetry is x equals 5. It's the x-coordinate of the vertex. Okay, I'm going to go with it. X-intercept, if we set y to 0, two numbers that multiply to 9 and add to 10, negative 9 and negative 1. So then the x-intercepts are 9 and 1. Okay. I feel like there should be questions, but again, I can't make you guys ask questions. The y-intercept should be 9. Because if you let x be 0, the only thing left is 9. And then the graph. Now we didn't write it in standard form. Let's see, can we see some of our results from earlier? We got a y-intercept. Okay, we had the vertex as well, right? We got 5, negative 16. Okay, let me try to use this. Five, negative 16. And then x-intercept, we got 1 and 9. So there's 1. I think that's all that we need. Okay, we're gonna go with this for now. Now we probably should go through and like verify that everything matches up. Like the vertex we said was 5, negative 16, so 5, negative 16 is there. Axis of symmetry is x equals 5, so you can see that. The parabola opens upward. We got x-intercepts of 1 and 9, so those both work out. We got a y-intercept of 9, so you can see it there. And yeah, I mean they all check out, so we're just gonna go with it. Okay. I kind of want to kind of get off of this one and kind of work on with the time that we have remaining, like 3-1 and 6-4. I'm gonna go ahead and submit this and see how do we do on the questions that we worked on. Submit the test. Let's see. Looks like for whatever we worked on, we got them. We did okay. All right. Okay. So then let's hop to section 3.1. Let me leave that for right now. If I go to 3.1, exponential functions, review and practice. It's fine. I'm actually going to work backwards. Actually, let's start at the beginning. Let's start here. Okay. So then, let me check some things. That looks good. And I think you guys can see it as well. Okay. Check one more time. Okay. So given this function, find g of -1, right? So these are exponential functions. So when x is -1, if we plug in -1 for x, we're going to have 1 minus -1. So double negative is positive, so 3 squared, that's where that 9 came from. I'll go ahead and use the answers. For this one, you would have to use a calculator. You would have to put 5 to the power of 1 minus 2.1. Done correctly, you would get 0.17. Given the function, find f of 4. So when x is 4, right, 1 minus 4 is -3. So negative exponent causes the fraction to flip, right? Negative exponent causes the fraction to flip. So then it's going to be 2 to the power of 3, and that's where the 8 came from. Okay, exponential of this form that contains the 2 points, right? So they give us the form c times a to the power of x, and we wanted to pass through these 2 points. So if when x is 0, y is 3. So if we plug in x is to 0, the a is gone, and we get that c is 3 pretty quickly. And then we use that when x is 2 and y is 75 to solve for a. Right? I'm just going to touch on that because we're kind of pressed for time. Let me see. I think my clock is doing okay there. Man, my energy just got zapped all of a sudden. Graph the function on graph paper. Okay, so this is 5 to the power of x. This is an exponential function, right? The only one of these graphs that behaves exponentially is d. The properties, the general shape of an exponential function, to the far left, it's really, really close to the x-axis. It's almost 0, but it's not there. Remember that there's always space there, right? So because there's a horizontal asymptote in the x-axis for exponential functions. And then going off to the right, it goes off to positive infinity. Okay, I'm just going to kind of go forward. Sketch the graph of this by making a table of values. Notice, let me see, this is larger than 1, but then you have a negative exponent, so it should be exponential decay. So then it has to be either C or D. Let me see. So then to confirm whether it's C or D, I would just choose several values of X, find the corresponding Y, and compare. Or you can put it in your graphing calculator and like just make the windows the same. Then you can just like compare and contrast. Match the graph to one of the following functions. So this is an exponential function that's been flipped vertically. All right, so the negative needs to be on the outside of our exponential. So I think C is the only one that does that. Multiply the outside by a negative. Okay, so if we're using transformations, right? The basic shape is an exponential, so it starts off flat, then it takes off quickly. But then this +1 on the outside means that we move the whole graph up by 1. So you can see where it's been shifted up by 1. Okay. Sketch the graph. Describe how the graph can be obtained. So basically it's transformations again, right? So we have an exponential function. We have 1, 2, 3 transformations. So whenever you're doing like multiple transformations in succession or whatever, I usually work my way from the inside to the out, right? So the innermost nested transformation is this -1, this x -1, right? So because we're subtracting 1 on the inside of our basic function, that says to go to the right by 1, right? So that's why you see this right here, to the right by 1. Next is we're multiplying the outside of our basic function by 5. So that causes a vertical stretch by a factor of 2. I'm just kind of touching on this, so, so to say, hey, it's a good idea to go back and look at transformations. And then we say +3 moves the entire graph up by 3. Right one, stretch vertically, again by a factor of 5, and shift up 3 units. Okay. So again, just a basic exponential function. It says to go right 4 and then up 5. Okay. So if all we did was move to the right 4 and up 5, the domain being the very left to the very right, the far left is negative infinity, the far right is positive infinity. What's the range? The very bottom is 5 with the parentheses, right? Because I know it looks like it gets on the 5, but it doesn't. There's actually space between our graph and 5. Y = 5 is a horizontal asymptote, right? Okay, let me see. How long have I been streaming? Okay. Let me see. Oof. Yeah, I can't really think of anything else. Let me take a few more minutes. Let me just kind of keep scanning through this really quickly. I don't want to keep you much longer. I just want to try to touch to see if there's anything else I need to mention. Interest, so you might want to take a look at interest again. Simple interest, compound interest, and continuous compound interest, right? This is an example. This should be simple interest. I equals PRT, right? So simple interest, principal times rate times time. We multiply those. Also, whenever we're doing interest, the percent symbol has to be converted to a decimal, right? So 15% as a decimal is going to be 0.15. The time, whenever we're doing interest formulas, the time has to be in years. So you have to convert months to years in this one. So the money, the principal you can leave, rates have to be in the decimal form, and the time has to be in years for these to work. If you just multiply those numbers as you see it, it's not going to work. Compounded monthly, right? So this is compound interest formula. I'm just going to redirect you just for the sake of time to look at compound interest formulas again. Okay. I think energetically I am spent because I am like fading for some reason. Okay, guys. So yeah, it's been great. I wish you all the best. I'm proud of you guys. Keep up the good work, and I'm available if you have questions or if you need help with anything. And again, I'll be in communication via the announcements in Blackboard with details on the final. And also, again, you can anticipate our stuff to lock out this upcoming Monday. As far as the old assignments, like the exams and quizzes, if you're trying to boost your score, like your grade, if you don't do anything else, you definitely want to make sure that your exams are in order, right? You don't. I wouldn't worry so much about the quizzes and homework because that's like 10% each, right? So that's a lot of work for a little bit of points. And also, if you have a lab, just what I'm planning to do there, whatever grade Dr. Lamar puts in Blackboard for you, I'm going to take that and scale that to 10% of your overall grade. Whatever we've been doing together is like 90% of your grade, and then her component is 10%. Okay? All right. Good luck, everybody. I wish everyone the best. Happy holidays, and I'll see you next Thursday. Take care.